Hi, everyone. Thanks to Frontend Northeast for having me on. It's nice to pay you back for all of the pizza that I've been eating for the past few months. Sorry if I'm a little bit loose. This is the first time I've been out of the house in a week because I've been ill, so everything feels a bit weird. But bear with me. Okay, so yeah, my name's Sean, and I'm going to be talking a little bit about a sort of weird kind of hobby project that I made a while ago. In terms of contextualizing it, it might be useful to know a bit about me. So I am kind of first and foremost a bit of a lurker at these meetups, I guess. I'm a kind of new-ish web developer. I'm looking for a job. Give me a shout if you know about any of those things. I worked as a computational artist, and I'm a recovering academic. I've built and performed with software and hardware for art and music that's been put in table football tables, it's been strapped to dancers, nailed to trees, put in art galleries and dragged through rivers and that sort of thing. I'm also a musician. I'm an exiled classical violinist, former multi-instrumentalist, and my main way of performing music now is I write and project code live on stage in nightclubs in various parts of the world to make music that people dance to. But that's another story for another day. So with that in mind, the question of the hour, I guess, is what does the front end have to do with bell ringing? And you'll be pleased to know that the answer is like nothing, really. When I was learning how to create and implement things for the web, I'd done plenty of your standard, like my blog with React and, hello world lorem ipsums. And I wanted to do something a little bit more interesting to kind of get my teeth into something that I kind of was a little bit more familiar with. As I described, I'm a musician and I've always been fascinated by church bell ringing from hearing them kind of in and around Newcastle when I was a kid. The way the bells would be rung in particular, where's my mouse? In particular sequences and permutations was something I didn't really know much about. So I thought maybe a good way to get to grips with it would be to make a web tool that I could use to kind of simulate church bell ringing and maybe visualize how these patterns work. And if it was on the web, people would theoretically be able to use it too. Okay, so what did I need to make a church bell ringing simulator for the web? Okay, so first I needed to think about the things that I could use to build it. So change ringing is a really complex subject, and I don't actually know that much about it. But essentially, you have a number of bells, and you ring them in sequences. And every time you ring the sequence, you switch up one pair of bells at a time that cuts down on kind of movement, different bells getting in the way of each other and stuff. And when you ring the bells in different sequences, it generates particular melodies. One way to manage these sequences is using a thing called the Steinhouse-Johnson-Trotter algorithm. It's a permutation algorithm, which means that it generates all possible combinations of a sequence. But this one does it in a particular way where it only swaps two adjacent elements at a time, which is how change ringing is performed. Incidentally, it was discovered by three different mathematicians independently of each other in the 1960s, but was well known to English change ringers as early as the 17th century. So they got beaten to it, I guess. So that's the algorithm I needed to make these sequences of bells, but I'm not someone who has the firmest grasp on these kinds of like formal maths and that sort of thing. But luckily someone had one written and had it on GitHub in JavaScript, no less. Shout out to this guy, No Dash, or this person, No Dash, rather. I assume it's none of you. No? Okay, cool. Thanks anyway. So using that, I could generate complex, kind of these complete permutations of any given set. So I needed to turn that into bells or something resembling bells that I could use to play those permutations. I make music using a language called SuperCollider, which is a language that's kind of custom built to work with an audio server. So I'm a bit spoilt when it comes to applying computational processes to music. And browsers don't really have the best sense of rhythm, I've found. But Tone.js is a sort of nice library that's built on top of the web audio API that's designed for scheduling, which is really useful, as well as creating oscillators and synths and effects, which is the kind of process that I'm used to working with in SuperCollider. So with that, I could create a kind of bell instrument, if you like, which could have notes triggered at particular intervals set by a unified tempo. to sanitize the data coming out of the permutation algorithm, I would give it a list from 0 to 8, and it would spit out a huge list, a list of lists. But 0 to 8 can't really be interpreted by Tone.js. It needs note names. So I use a library called Tonal, which is by a guy called Dan IGB, which is a functional music theory library that would allow me to take these numbers or indices and turn them into a set of note names that could be used by Tone.js. My kind of background in music helped with kind of decoding a bit of that, for want of a better word. So I had an algorithm to generate the permutations, and I had something that I could kind of sound them out with. But I also wanted to visualize those sequences so I could see which notes from the sequence were being played. So to make some kind of system to visualize the bells, I kind of fiddled around for a while with sort of a few different things. And I decided to go with a library called conver.js. This kind of thing isn't really my wheelhouse, so I mostly ended up just sort of poking around with it until it worked, and then like leaving it the hell alone so that I didn't break it. But it can animate things on an HTML5 canvas, which seemed perfect for what is essentially just like a basic data visualization when I needed something to light up when a sound happened. I needed to take this list, and every time a bell rang, I needed it to flash. Easy, right? Okay, cool. So we've got sound, we've got visuals, we've got an algorithm. How do we kind of glue it all together? I decided to glue it all together with React components, and I'm sure a lot of you know about React components already, so I won't go into much detail there, but I could make a bell ringing unit and just copy and paste it and make multiple ones, and that way I'd be able to have multiple of these kind of bell ringing sequences happening all at once, and I could kind of have them all synced to a nice tempo and then see how they kind of played off each other and make components for things like volume and tempo and so on. So I guess those are the 4 elements of the system. I think the best way of explaining how things came together would be to just show you the end result and kind of talk through it a bit. It's not the best looking thing in the world, but it seems to work pretty good. But bearing in mind I am on stage right now, I don't know if I did the appropriate blood sacrifice to the tech demo gods. So, I may have spoke too soon. Okay. So this is it. This is just a bunch of information that I kind of already told you. So what we've got here is 4 loops, which will take the form of kind of bell ringing sequences. You boot one up. You can put a bunch of indices in. So, minor chord would be 1, 3, 5. You can choose a root note. I'll stick with C just because it's easier. Octave controls basically how high or low the sound is. You can specify a key. Tonal has, as music does, has like a million different scales that you could use. So rather than have like a drop-down list with a billion things come in, I just started off with major and minor, and a couple of friends who tried it out said, oh, can you put in Dorian? And oh, can you put in chromatic? So I just sort of slammed those in there as well for good measure. And a duration. So you pick kind of these sorts of things, and then you create a loop. So now what's happened is you've got your original scale. You've got the number of generations that are possible to make with that scale. So with 3 notes, there's 6 possible sets of permutations that can be made with those 3 notes, I think. That makes a total number of notes of 18. So we've got a bass line. Oh, that sounds horrible. Great. Yeah, this is mostly using kind of pretty simple sort of sine waves and stuff. So in this room in particular, it's going to sound like garbage. Sorry about it. Great, okay. So, another component here. You just kind of pass in a color as a prop and it just kind of loads up. What else do we need? Let's kind of do something like that again, but a bit faster and a bit higher, I guess. So you can see we now have 24 possible sets of permutations with like a total of 96 notes in the sequence. The white light that's coming up shows which note in the original sequence is playing. So as the generations get further and further from generation 1, it'll get kind of more and further from the original order. Let's have a nice little minor scale. Shouldn't have really picked a minor scale. It's a bit morbid for this kind of occasion. Again, like, sorry about it, guys. Here we've got 40,320 possible generations with, I'm actually at such an angle that I can't even read how many notes, but it's a lot, guys, it's a lot. As you can probably hear, there is a little bit of slippage in the timing. Can't quite work that one out. There's also a problem with tempo shifting. So you can shift the tempo with this thing. But it tends to make things stop working, and I don't know why. I think that's a bug with Tone.js. You can also just add things that sound totally horrible, of course. Oh, it's crashed. Yes! This has never happened before. Ah, incredible. All right, cool. That's never happened before. Brilliant. All right, cool. Really glad I could bring that excitement into everyone's lives there. Okay, cool. So, cool. Yeah, that's the link, but it'll be on the last slide. Okay, so problems with it. I probably could have actually just used CSS instead of using Conver. CSS is kind of much more my wheelhouse than the Canvas stuff is. So truthfully, like, I don't know why I didn't just do that in the first place. There's some, as you have seen, there are some bugs with Tone.js that mean that like stuff like on-the-fly tempo changes do tend to just break stuff and they just silently fail. I'm really used to fiddling around with really stable music systems, so you know I'm a bit spoiled, I guess. It needs a bit of a refactor. The base unit code's clunky and could do with being condensed and extracted into subcomponents, yada yada. But like, what hobby project doesn't need a refactor? Like, let's be honest. And it doesn't sound very good. A friend of mine compared it to old Zelda music, and it's just really stuck. Which is fair. I mean, you might think that that's a good thing, and like, fair play. But to be honest, it's because I didn't spend the time like really crafting a good synth. And if I wanted to, I could, you know, set up some reference monitors and really craft something crisp. But I don't think I'm going to. It's basically just a proof of concept that's gotten extremely out of hand. And that's everything. Thank you.